So today we're going to discuss the electrical conductivities of various substances and how this is important for the electrical safety of us when dealing with these electrical devices at home or at school or in the community. Here we have sugar, tap water, salt, a pencil, a coin, and a ruler. And we are going to test them using an electronic circuit in front of us, which consists of some wires that are joining to a bulb, and then from the bulb leading us to a battery. So let's see if actually this circuit is working by joining these two disconnected wires. And yes, our bulb does light, which implies this is a working circuit. So we are going to do some tinkering and we disconnect the wires here and try to understand what electrical conductivity is. So if I bring a material in between these two wires and it leads to our bulb lighting, then we shall consider that material or object a good conductor of electricity. And if I have a material in between my two wires but my bulb doesn't light when I complete the circuit, then that will be a bad conductor of electricity, which we all know as, that's right, an insulator. So let's try adding a pencil to our circuit and see if it's a good conductor or a bad conductor of electricity. And yeah, it's actually a good conductor because it has been able to light up our bulb in the circuit. So a pencil is made of two materials. First is the outside wood, and then the inside part that we use in writing is made of graphite, and that's the pencil lead, the black part that you all see. It's made of graphite, and graphite is a form of carbon, and carbon is a good conductor of electricity. So let's try using sugar and see if it will actually light up our bulb. So when I join the wires, I see that sugar actually isn't lighting up the bulb. So this means sugar is a bad conductor or an insulator. So let's also try a piece of plastic. This is a plastic ruler. Let's try and put it in our circuit and see if it's a good conductor or a bad conductor. So our bulb isn't lighting, so this implies that plastic is a bad conductor of electricity. So here with me I also have distilled water, so let us try to see whether it's a good conductor or bad conductor of electricity. So what is distilled water? So this is just water that has been boiled into vapor and condensed back into liquid in a second container. So let's try and see whether it will conduct electricity. And when you look at my circuit, the bulb doesn't actually give us any light, which implies distilled water is a bad conductor of electricity. So this also means that distilled water is actually a form of purified water because it has no dissolved ions and impurities in it. That is why it has not been able to conduct electricity. So let's also try using salt in our circuit and see if it's a good conductor or a bad conductor. So we can all see salt is not able to light our bulb in the circuit, which makes it a poor conductor of electricity. Salt was unable to conduct electricity, and that's why it was not able to light up the bulb in our circuit. And this was because mainly salt is made up of sodium and chloride ions that are attached together hence making it an insulator. But if I add this table salt to the distilled water, I will be able to detach the sodium and chloride ions that are attached together in this table salt. So let me do this, and we see whether our distilled water will now be able to conduct electricity. So I can go ahead to stir my distilled water. So now let's find out whether our previously distilled water, now mixed with salt, will be able to conduct electricity. So when I join my wires here, and now you can see there is some reaction in my distilled water mixed with salt, and then I can also see a dim glow on our bulb in the circuit. So initially our distilled water that had no impurities in it and any dissolved ions in it was not able to light up the bulb in our circuit, but after adding some table salt, we can now see it lighting the bulb in our circuit. So what does this imply? It implies that the sodium and chloride ions in our table salt that were attached together initially have now been dissolved and detached when placed in this distilled water. And I think we can now go on and try out using normal water in our circuit. Normal water being tap water, though you should do this with supervision from your parents. So if we leave the wires in water for some time, we are going to observe some bubbles around our wires, and this implies there is a reaction between the tap water and the wires. And then for the bulb, you can't see the light, but it produces a very dim glow. So the bubbles that you saw around the wires indicate presence of dissolved ions and other impurities in our tap water. Hence, tap water is not purified water. Since our tap water contains some dissolved ions, and we have salt here, which actually is composed of sodium and chloride ions, let's try adding some salt to our tap water. So let's stir and see if our tap water will now produce a brighter light. So now that we are done with stirring our tap water mixed with salt, let us see if our bulb lights brighter with more salt. So we can all see in our circuit the bulb is lighting brighter than it was previously, and this is because we've added more dissolved ions. That's mainly sodium and chloride ions. This means that tap water is not purified water, since it contains dissolved ions and impurities in it that do conduct electricity. So this is why we are at risk of being shocked by electricity when we touch electric appliances or devices with our hands wet. Before we go, here are some electrical safety tips for the children and also for parents. Do not touch or put things in power outlets without your parents' permission. Never touch or climb trees that are near power lines. Then, never touch or play near big metallic transformer boxes with warning signs and symbols. So for the parents, please child-proof your home by hiding all power outlets or plugs to keep curious kids safe from the temptation to stick foreign objects into plugs or outlets. Then put all electrical devices such as DVD players and decoders on a shelf out of reach or behind a barrier. Then finally, please parents, store all bedroom and kitchen electric appliances such as flat irons and power extensions out of reach of curious children. So So thank you for watching our video. If you enjoyed, please like and subscribe, and if you have any comments or any questions, please leave them down in the comment section below. See you next time.